Okay, I've got this question here. I'm sure you were able to look through quickly and get some marks, and we are going to answer the questions together. First thing is to look at the type of generator that we have. And luckily for us, we were told that it's an AC what? Generator. Write down the name of the part labeled R. Those are what? Slip rings. Remember, split is what? The DC. So these are called slip rings. Slip rings. Okay? And what is the function of the slip rings? All right. Allows current to do what? To change direction in every half cycle. Remember, because it's an AC generator, we are expecting something that looks like this. The current changes in every half cycle. Current changes in every half cycle. Already we've answered the whole of question 9.1. It says, name the part and the function. State one principle on which an AC generator works. What is that principle? Faraday's law of electromagnetic induction. And every time I do this, I would always show you the simulation of how it works. We are producing electricity from a magnet, hence electromagnetic induction, the word induce. The word induce. Okay. If the armature is rotated in the direction as indicated in the diagram, which way will current flow? Here you know you need your rule. Either right hand or left hand. But it's a generator. What do we use? The right hand rule. Okay, generators right, motors left. And if you do this, okay, for those of you that are here that you can see, my thumb, if you're not here and you're at home, just try to use the screen and listen. Your thumb is pointing up, right from the north side. We always point to the south. Now, if I were to do that, it means my second finger would actually be pointing in at this point. All right. So you're pointing to the south. Your thumb is pointing up. Your second finger would be going in from the north side. So current would be going this way, and I think we've answered our question. Is it from A to B or B to A? A to B. I want us to practice it's 1 mark. It can waste your time though, but with something that we need to get. And it's a generator. We use our right hand. It's the same way. Motors, you just use left. That's the same principle works. I wish I could have. Let me try something for those of us at home. Let me see if I could get something here quickly. Because I want you to see. There was something I used some time ago. Let me see if I can get it for you. Just a moment, because I want you to see. Let me see if I can get a picture that would rhyme with this. Yes, sir. Yeah? Yeah, motion, field, and current. I want us to see. I want to get a picture. So that those people, those who are at home will be able to also see. Let me see a picture that would work well for me. All right, this thing is not really. I'm looking for something I can rotate. Okay, I'm just going to try. Let me see if I can try to rotate one image and see if it would work. I need a complete 3D image. There was one I got some other time and I don't know where it is. Okay, let's try this. I'm just going to try. I hope it works. And I just don't want to switch on my camera now. But let's see. I'm going to try to see if I can rotate this one. All right. I'm just going to try. I'm not promising you that I'll be able to win through. Okay. All right. The problem with this one, it would have worked perfectly, but it's a left hand. It's a left hand. I can tell. I can tell that this is left. But the thing is, okay, guys, for those of you at home, just leave test me alone. For those of you at home, this finger is in the right direction, pointing from here to here. This one is pointing up, telling us that it's rotating what? That way, because we're pushing it up. The only difference is this is a left hand. If you were to use your right hand, this finger will be pointing into your screen. If you use the right hand, it will be pointing into the screen. So you can try that and let me know if you got it. Right hand. Right hand. Please let me know if you got it, if you were able to get it. I need a response from you all. I need a response from you. So you are doing the exact same thing. Your hand is pointing here. All right. North to south. You are pushing up to tell us it is what? Clockwise. But this one, okay, here they used a left hand. All right. But if you use your right hand, this finger is the only one that is different. It goes in. So it means current is moving that way. Please respond quickly. Thank you, Ashley. Idris got it. Yeah. All right. So I'm hoping we all got it. Thank you so much. So you find out. So guys, they would always give you two. Just match your hand with the two. The third one automatically, and it must be 90 degrees. 90 degrees. Sometimes we do that as if you're shooting a gun, and that doesn't work. It's 90 degrees. Okay. Let's go on. 9.4. What effect does changing the polarity of the magnet have on the output voltage? Now, hold on. They said, what effect, let's understand the question, does changing the polarity, what does that mean? Okay, so if we switch, that's the polarity of the magnet, right? So if we change the polarity of the magnet, this now becomes south and this becomes north. They said, will it affect the voltage? Increase, decrease, or remain the same? It remains the same. Let's quickly discuss. What are the things that affect voltage?
The turn, changing the strength of the magnet, increase the speed of rotation, and increase the turns of the pole.
All right. What are the things? Number one, things that will affect voltage. Okay. I know we don't longer use this formula, but that's how we explain it, right?
We don't know the formula.
Okay, all right. But this is the formula we use. What are the things that we'll talk about? We'll talk about what? Number one, the number of what? Turns. The number of turns of wire on the coil. Is that fine? Number two, the speed of rotation. And what's the third one? The strength of the magnet. These are the things that will affect current, not this change of voltage. So these are the 3 points. And, that's how we answer now. When we look at a question, we quickly go deep into it and take that out. Elvic, make sure you are pointing to the south. All right. You are pointing to the south. Then you'll be able to get it right. Point to the south. So it's like you are describing. Okay, guys, so what's our answer here? Remains the same. Okay? What is the position of the coil relative to the magnet when the output voltage is at minimum? The position of the coil when the output. Look at this position. Let me just ask you, do you think we have maximum or minimum? This is maximum. This is maximum. All right, let me explain this quickly. At this stage, when your coil is like this, all right, we are going to have maximum current. That is the North Pole and that is the South Pole.
Why?
I'll explain why now. If you have North and your South Pole and the coil is, I don't know if you can see what I've done. It's now standing vertical. So the coil is now what? Vertical. Is that fine? We are going to have what? Minimum. Sorry, 1 second. Coil is horizontal. Let me just quickly do some explanation here. I'm hoping to answer all your unasked questions. The field is running parallel there. Is that okay? That's the magnetic field. Field here, magnetic field, is what? Parallel to the surface of the coil. Surface of the coil. Here, we're looking at an angle of what? 90 degrees, right? Because your coil is standing. Let's do that. So here, the field is perpendicular to the what? Surface of the coil. I'll draw a simple graph for you, doing a lot of things at once. Okay. When your coil is horizontal, we are going to be there. When your coil is standing here, we're going to be here. When the coil is horizontal again, because it's rotating now, it's going to be a negative and 0. So that's what we have. And what is this? It's because you guys don't do grade 11 anymore. To calculate this, we normally say delta phi phi equals to BA cos what? Theta. That's the formula. It's grade 11. All right? BA cos theta. When will I get this? When this thing is what? When this is 90 degrees. What will be your answer? 0. Check the angle here. Cos 90 is 0. But check the angle here. It is cos what? 0. Because those lines are, the coil is parallel to the what? Surface. And cos 0 is 1. And that's the maximum value for cos. We're going back to 3 graphs. So please take note of that. The position of the coil. I hope it makes sense. Please let me know, everybody. Guys, please let me know if it makes sense. Hi, Tesmia. How are you? Welcome. Not this Tesmia here. Tesmia Umar. How are you? Okay, yeah, Butle. No, they're talking about minimum voltage. So we're looking at minimum voltage. So if I talk about, this one is just telling you the direction. You see, this value is just telling you negative. Means in the opposite what? Not negative value per se. That's why we call it AC. alternating what? Current. So the magnitude here and the magnitude here are the same. It's just showing us that is what your slip ring does. Make current flow in different what? Directions. So basically, when we say minimum, this is our minimum. This point is maximum in opposite what? Direction. I hope it makes sense. Yes, sir. And this point also is maximum. So please take note of this explanation. When the field is parallel to the surface of the coil, we have what? Maximum. But when the field, magnetic field, right, is perpendicular to the surface of the coil, then we have what? Zero current produced. I'm good, Tess. It's just this other Tess here that is. All right, they said I should tell you that Bibi and Tess give salams. Are we okay? Salam given. Salam proven. Given. Confirmed. All right, guys, are we okay with this explanation? Please, very, very important. And they will ask you to draw this graph. That from position. Check this, guys. If I want to draw, please look up quickly. If I want to draw one full cycle, position where the coil is, please don't just draw. We read the question. Okay? So I want to draw from the position where the coil is. Look at this diagram. Where's the coil? It's horizontal, right? So we're expecting what? Maximum. When you draw, you must start from there now. And that's one full cycle. Because this is at maximum. They can start. The examiner will say from the present position of the coil. What about this one? This one is what? Minimum. That's what you see now. So please check the difference. This one, the current here is maximum. So we are starting at maximum. Here, the current here is what? Minimum. And the minimum is basically zero. We are starting at what? Minimum. So don't just draw. Yes, Leslie, what's your question? Okay, Les. Unrelated. Leslie. Let it be related. Okay, let's move. Oh, Leslie, okay, we're going to do work, energy, and power, so relax, we'll get there. We'll get there. Guys, are we okay so far? All right. I think we've answered this question now, right? What is the position of the coil relative to the magnetic field when the output, we said it's what? Horizontal? No, minimum. Vertical, right? But I would appreciate, don't just say vertical. All right? Let's explain. That's why it's 2 marks. What are we saying? The magnetic field is what? Perpendicular to the what? Surface of the coil. Okay, so this is basically much of grade 11 work tested here. You already have that note. All right, let's see this. The graph shows the potential delivered by an AC source to a light bulb, which is dissipating what? 15 watts. Please, a quick one in here. When you see this as power given, all right, please understand, use your formula page. The formula page says P what? Average equals to what? I RMS and V what? RM. It means whenever we talk about average power, we are referring to what? RMS. Use your formula to guide yourself. So power is associated with our RMS voltage. And we must be able to define RMS. Okay, Butle, I know that we have a discussion on this RMS voltage. All right, can we define RMS? Okay, Butle, you want to go? RMS voltage. All right, it is the AC voltage, since we're talking about voltage here. All right. Uh-huh. That dissipates or produces. All right, that dissipates. And if you forget the word dissipate, please don't crack your head. Produces what? The same amount of what? Energy. Amount of energy as a DC what? Voltage. If the examiner says current, then the voltage changes into what? Current. It's one definition that always just finds its way of escaping people. All right. What DC voltage will have to be supplied to keep the bulb burning at the same brightness? We're looking for what? Voltage, right? That would be supplied to keep. Look at the question. What do we have in the question? Let's make a list. Let's make a list of what we have. Make a list of what you have for me quickly. Look at the graph. Remind you, they gave us what? They gave us power, right? And if they give us power like that, they're talking about what? Average power. Okay. Let's check. So we have P average as 15 what? Watts. What else do we have? We have the maximum what? Voltage. Vmax. What is Vmax? 17 volts. Now, what are they looking for here? Huh? That's what they ask. They give us the definition of RMS, because check, the DC voltage which would have to supply to keep the bulb burning at what? The same brightness. What are we looking for? VRMS. We're looking for what? So if you don't know the definition, it's going to catch up there. We're looking for V what? RMS. Please, everybody, formula page. So they gave us maximum. If you check the definition, you'll be able to link the two. All right? The AC voltage that produces the same power as a DC voltage. Now, what DC voltage? Makes sense? Okay. They didn't ask you for the definition, but now they're asking for it. What's the formula? V what? RMS equals to V max over root 2. What do we have? 17 over root 2. And what's your answer? Wrong, baby. All right, now it's correct. Guys, can you walk through? Are we okay with that? Can you quickly walk through 9.6.2? I need us to go into mechanics and all of those. What is the what? It's important when you read the question and make a note. What is the peak current? What are we looking for? Imax. Through the bulb while it is connected to the what? AC source. We are looking for I what? Maximum. Guys, I chose this because I wanted to get all the 19 marks here quickly. Imax. All right. What do we have? I think we can even walk through from this formula. We have what? Vmax. We have VRMS. We've got power. So power is what connects your... It means there's an extra calculation that you need to do. So let's walk through it. What's our formula? P average. Please, your formula page is very important now. IRMS multiplied by what? Do we have VRMS? Yes. Do we have IRMS? No. What are we looking for? IMAX. But before you get IMAX, is it okay to get VRMS? For me, I just like bringing the formula in. Let's see. Will it work for you? What is my IRMS? I max over what? Root 2. Are we okay? Or let's do it separately. Whichever one you want to do. I don't know. I don't know. For me, I would have just brought in I max. Yes, it's the same marks. The same marks. But let's do it separately for everyone. What's our power? 15. Do I know IRMS? No. Do I know VRMS? 12,03. So what is our IRMS? Let's do the maths. 1,25 amps. But this is not where we are going, right? How do we then get our IMAX? IRMS equals to what? IMAX over root 2. What do we have? 1,25 equals to, for me, if you just make a list of what you have and what you are looking for, life becomes very easy. What's your answer? Thank you, baby. You get your 4 marks there. Please talk to me, guys. Are we okay? Are we okay with the calculation? I need us to move as fast as possible. Are we okay? Everybody all right? Are we okay, guys? All right, look at the last question. Draw a graph of current versus time for the what? Time period as the... Look, we are drawing exactly the same thing. The only thing they want to mark is, do you know this? And do you know where your IRMS is? Okay, can I use the same graph? Guys, we are drawing the same thing, only that... Okay, let's draw because we need the values. We need the values. But you see the way the graph is, right? So we're drawing the exact same thing. And some of you might not know where the IRMS is. Today you would now see. So we have the same graph, right? Good. Where is our IMAX and where is our IRMS? That maximum. And just below it is your RMS. So please, let's take note of that. This is I maximum. What is this? I what? Did we calculate our I max? 1, what? 77. Did we calculate our RMS? 1,25. And what is this? I in what? Amps. And what is this? Time. In seconds. The graph? Current versus time. And we're done, guys. 19 marks. So please, I'd like you to focus a lot on this topic and get your marks. It ranges from 15 to 21. Okay. Everybody okay? Now let's go and answer where learners normally. So please, I just took this so that you answer as many questions as possible. Use this information. This topic is a topic where marks, please, and not just marks. At least 99% marks out of 100. The topic. These questions are always straightforward. But I can okay, let me do something here on this while I'm on this. It just crossed my mind because we may not even come back to this again. When we change current, we mentioned 3 things on how we... I think the next lesson I'll do a motor. If we look at generators, when we change current, all right, changing current, we spoke about three things, right? Do you want to talk to me about changing current? What did we say in a generator? Number one, what did we say? Speed will affect, right? Speed of rotation of magnet. All right. Now, I'm going to do something here that may confuse you if you are not focused. The number of what? Turns of wire on the coil. Let's be specific. And number three, what? Using a stronger what? Magnet. Please look at this. I want to just do this in a graph. These two will not affect the period of your graph. While this one will be the only one that will do what? Affect the period. Somebody's confused when I say affect the period. You are confused. I'll help you now. Check this. Thank you. It's the number of full wave will be affected. If I have this, all right, we have points 1, 2, 3. If I have this graph, I have done a change. This graph represents 2 and 3. We are not affecting the period, the time for one complete wave. But if I then come here and do this, I'm using the green one now. What do you notice? This is the speed, number one. It means I am having two periods in the cycle of. This is now in physics or in math. We'll say cos 2x or sin 2x, where we have two graphs in the space of one period. So let's take note of the graph there. The green one, when you change the speed, it affects the period. So you have two waves, more waves in one full cycle. So an examiner can throw that in, possibly in multiple choice as well. So let's take note of that. All right. Can I move on quickly? All right, guys, let's quickly answer now some rotation of the coil. Yeah, the magnet or the coil can rotate, either of the two. Or the coil, depending on the structure of the whole thing. All right, can I move on quickly now? Take a picture. All right, guys, let's answer a few questions, please. Multiple choice. I know we don't like it. Number one, quickly. Which of the following is a conservative force? I've taught you how to identify conservative forces. Conservative. We don't even have to waste time on this. When we say non-conservative, what are we talking about? Your non-conservative are this. And what is this? Friction. Applied. Check all the other options. Do you notice it's just fat? Check all the other options. Friction, applied, tension. Does that make sense to you? The only one that is not in the fat is what? Gravitational force. We're done. 2 marks. All right, look at number 2 quickly. I'll give you 2 minutes. All right, an object with mass m moves with constant velocity. Please, this is physics. I'd like us to read and interpret. Once they say constant velocity, acceleration is equal to what? 0. It undergoes a displacement Fx. Please understand. A displacement t seconds in the presence of what? Frictional force F. How much power is at constant velocity? We're looking for power. How much power? Now, if you check your formula page, what's the formula for power? For motion. Power equals to what? Force and average force. Please, let's check. Check your formula page. You'll find that. Power is average what? Force times velocity. Okay, so we have object M moves in a constant velocity. It undergoes a displacement. There. Everybody, please find that formula for me. P average is, it's P average is equal to what? The average should be here. Force times what? Average what? Velocity. Is that okay? Let's check something here. Do you notice this formula has no velocity? Right? The answers, there's no velocity there. Okay, it says it undergoes a displacement of Fx in t seconds. What is our velocity? Velocity is what? The change in displacement over change in what? Time. Already I know now my velocity is what? What's my displacement? Fx over what? T. I'm already bringing that here. Fx over what? T. That's the first thing we're getting. Make sense? All right. They said it undergoes a displacement of that in the presence of what? Frictional force. How much power is required to keep the body in motion at this constant what? Velocity. It means the force that we are using must be equal to the frictional force. I don't know if that makes sense. Let's check something. Because of constant velocity, we know that acceleration equals to what? 0. And what do we know? F net is equal to 0. Make sense? How do we get F net? There are two forces here, right? Applied force minus friction equals to what? 0. Does that make sense? Because now, that's you interpreting now. If there's friction and something is kept at constant, said how much power is required, it means there's a force applied here. Isn't it friction is reducing the speed? Right? Friction is reducing the speed. But now you want the speed to be constant. You must be doing something to work against that friction. Make sense? All right. And we know that F net equals to what? 0. So these two forces, F is equal to what? Fk. All right. Friction is acting on the object. What will friction do? It will reduce the speed of the object naturally. But now the object is kept at constant speed. How do you keep that at constant speed when there's friction? You need a force that is equal to what? Friction. So that the object, okay, Butle, I have this object, this surface, right? There's friction. Friction is acting what? This way. What would happen to the speed of this block? It will decrease. But I don't want it to decrease. I want it to be constant. So what do? Push. To counteract what? That. And because it's at constant speed, acceleration is equal to what? 0. And we know F net equals to ma. So F net is also equal to what? 0. It means F minus Fk equals to. So our force applied should be equal to what? Friction. To keep this at constant what? But now check. They said in the presence of frictional force F. So our frictional force is written as what? F. Can I bring that in? Do we have this option? So basically, if you see, this is F multiplied by what? V. So there were a lot of definitions that the examiner is checking there. Can you define velocity, displacement over time? Do you understand what we mean by constant velocity? Acceleration is equal to what? 0. F net also is equal to. So this is a lot of concept in one question. Please, can I get responses from the house, those of you that are here as well? Are we okay with what I just explained?
Yes.
Please don't jump into multiple choice. Where did I lose you, Tesmia? Okay, please take a moment. Let's read the question again. An object with mass m moves with a constant what? Velocity. We stop there. What is zero? No, it means velocity is not changing. Yes. So at constant velocity, acceleration is equal to zero. And we know that what? F net is equal to ma. So if acceleration is zero, net force equals to zero. That makes sense. Now, it undergoes a displacement fx in t seconds. They've simply given us velocity. Because we know velocity is what? Change in displacement over change in time. Yes. So velocity is the change in displacement over change in what? And do I know my displacement? Fx. Do I know my time? T. Now, so we are using this formula because the examiner says how much power. How much power tells us there is force what? Applied. So this is my formula. Average power equals to what? The constant force times what? Velocity. Applied force and velocity, right? Good. Now, F, already we got this, right? But the question is, what is this F? That is the F we are looking for here. Let's use force applied here. Force applied. Is that fine? So what do we have here? Force applied minus friction equals to 0. What is force applied? Equals to friction. But what is our friction? The examiner gave us as what? Capital F. So it means my force applied is F, which I brought in back there to give us F, Fx over T. All right. Can we move on? Multiple choice, please. You might need to go through this lesson again. Multiple choice has a lot of content that will be tested. What is the next one? All right, look at this. I want you to give me an answer. Guys, I'm giving you just 3 minutes. I want you to try this one. This one is quite straightforward. Please, everybody, 3 minutes. Look at it and give me an answer. Please, let's answer. I don't know. You read. I'll answer when I'm reading with you. Share your answers. Share your answers quickly once you're done. Guys, I'm waiting for answers. No one is giving me answers. What's wrong? If you are lost, please, tell me you are lost. You have 50 seconds now. If you are lost, tell me you are lost. And if you have an answer, tell me, just give me your answer. Two forces, each of magnitude 300 newtons, are simultaneously applied to the crate at rest on a frictionless horizontal surface as shown. The work will be done by the net force on the crate, and the crate will... Okay, Idris has a D. Bonga also had a D. You have an A. Whitley has an A. Okay, A. Oh, they copied you. You chose A. But can you, guys, what's the explanation? Newton's second law says the object will accelerate in the direction of the what? Net force. The question is, which one is the greater force? And you cannot compare 300 and 300. You only compare horizontal forces. This force is not horizontal. That's the problem. We need to change it into what? We need to find Fx. And mind you, remember, this one is what? This side is opposite. For opposite, what do we use? Sine. So Fx would be what? 300. Cos, it's not opposite. Horizontal is the... So what's the answer here? So which one is greater? The one on the left. So the object will accelerate to the left. We're done. Object will accelerate in the direction of the greater force. So the examiner is putting 300 there, trying to check, do you remember your component? So the object would move to the left because of a greater force. Please, you cannot compare a horizontal and an inclined force. If you are comparing forces, it must be horizontal. Idris, got that? A stone freely falls from rest from a certain height. Which one of the following quantities could be represented by the y? If it falls from rest, our initial velocity will be what? 0. Is that okay? But is this, what is represented here? Guys, let me show you one way to answer if you are lost. Can I show you something? Can I show you something here? This is velocity, right? What is acceleration? Change in velocity over change in time. So velocity is here. What is momentum? Mass times velocity. Velocity is there. You cannot have velocity in everything. It's a position time graph. That's how we draw the graph. It's if the object is dropping, right? It's dropping at an acceleration of what? 9,8. Your graph is a straight line graph. Initial velocity was 0, right? And what happens? The velocity increases constantly at 9,8. That's how it should look like if it was supposed to be velocity and time. Because the acceleration is what? 9,8. But should you get confused, check what I did. Found what is common. If velocity is correct, then acceleration is correct. If acceleration is correct, then momentum is correct. And 3 options. That's a little trick there. But understand that it's a free fall. Okay? So the velocity must be what? Constant, because A is equal to 9,8 meters per second squared. All right, lovely. Last one, I think. The ball is released from rest at point A, h meters above the ground. Why do I have Z now? It slides down and up a smooth frictionless track ABC. See the diagram. Okay, I don't understand why the Z. Okay, h meters. They said h, it changes from h to Z. Lovely. Okay. H meters. Okay, as the ball slides down the track, it will, okay, hold on. It has what? It's an isolated system. Mechanical energy is conserved. Is that okay? What is the velocity at point A? Initial velocity is 0. What is the final velocity at point C? Velocity is what? 0. Okay, what do we know here? Potential. Here, kinetic energy is also equal to what? 0, because half mv squared. Kinetic energy is also equal to what? 0 there. Are we okay? But here, potential energy is maximum. Here, but do you know why potential energy is maximum? Because it is mgh. It's at maximum height. But at the bottom, what's happening? Because as it comes down, EK is now increasing. EP is what? The swapping values. So at the bottom, EP is at what? Minimum. While EK is at what? Maximum. But throughout the system, mechanical energy is conserved. Having said all of this, do you think we can pick an option? As the ball slides down, it will have maximum kinetic energy and 0 potential energy at B. Check what we wrote down at B. Will it have maximum kinetic energy at B? That's what we wrote. But let's see. We'll see where the ground is. Roll up to a height of what? Zm. Okay, now they are talking about H and Z. Roll up to a height of Z on the opposite slope at C. Okay, remember, it's an isolated system. So, it should roll up to that point. It's isolated. Number 3, lose wrong. Completely, because we said mechanical energy is what? Conserved. Experience a gain in kinetic energy, which is equal to its potential energy at C. Will it gain kinetic energy? No. At C, it's losing. Okay, now, experience a gain in kinetic energy. No, when it's going to C, what's happening? It is actually losing kinetic energy because it's going up. So now, we have to answer between A and B. It cannot be A. Why? Because B is not on the ground. If it went on the ground, that's when would have what? A 0 potential what? Do you notice I did not write 0 there? Why? Because the height is not on the ground. If it were on the ground, here, potential energy would then be equal to what? 0. So the correct answer is what? B. It would roll up because mechanical energy is conserved. Lovely. Are we okay, everybody? All right. Newton's laws. I'm going to ask you to answer a few questions for me. Guys, we're running out of time. Okay, all right. Let's quickly, guys. I'm going to need you to answer very fast here. I need some marks here, quickly as possible. Elephants have been transported from Kruger National Park to Eastern Cape. They must just leave the elephants. I don't know why creating problems for us. All right, they are loaded into crates that are pulled. Let's read. That are pulled. It means there's what? Applied force. Up an inclined plane on frictionless rollers. The diagram below shows a crate with an elephant held what? Stationary on the ramp by a means of a rope parallel to the ramp. The angle of inclination is 15, and the tension. Already the tension here is the applied force. Please don't think there are two forces. It's already the applied force. You're not reading. It is held stationary. Can we answer 2.1, please? 3 marks. I need those 3 marks. Consider crate and elephant as one object. Please, everybody, those of you at home, draw as well. You would mark with us now when we draw. Quickly. Free body diagram. This is where we start getting the marks, guys. Let's draw quickly. What are we drawing? Applied force, right? Everyone should be done. Force applied. Oh, guys, we have that, right? What is that? Normal. What else? Is that fine with you? Okay. What is this? Force of gravity. What is this? Normal. What is this? Applied what? Okay. All right. Check this. They said the diagram shows what held on a ramp means by the angle of. Okay, there's something there. They said frictionless what? Rollers. But it doesn't mean that there is no. Okay, frictionless rollers. The surface, nothing was really said about the surface. So now, if you do this, do we think that there's friction or not? But it's not necessary that there's static friction, though. Why? By the time we resolve this thing, I'm using a different line. FG parallel will be acting this way. All right? So it means force applied is then equal to FG what? Parallel. Okay? So I think the question is a bit vague here in terms of the surface not being specified. All right? However, I would, as a physics person, for this thing to be kept constant, I need static what? Friction. The surface is the surface of the rollers are the one that are frictionless. It doesn't mean that the surface is frictionless. Okay? However, let's see something here. Draw a label acting on the elephant and the crate. Acting on the elephant. Just wait. Acting on the elephant and the crate. Let's hold on. Acting. I want us to read because there's a trick here. Acting on the elephant and the what? And the crate. Hold on. Can we redraw this diagram? Examiner is smart. They're checking if we are reading. Acting on the what? Elephant and the crate. Where's the crate? That. It's frictionless here. So static friction should be out. I hope it makes sense. They didn't say on. So the rollers are the one in between the surface. So if the rollers were not there, I'll put static friction. So the examiner says between. So let's read between the what? Where is it? Acting on the elephant and the crate. The crate is the box. These are the rollers. And here, right here, they said it's what? Frictionless. Make sense? All right, very tricky. Please, we're not using mark allocation to judge. We are doing physics. Okay. What do we have? The mass of the crate has what? It's 800. Can we determine the mass of the elephant? I'll give you 2 minutes. Determine the mass of the elephant. And don't write the elephant run away. Please, we calculate. That elephant run away, sir. Okay, let's make it 3 minutes. Because you have to do a bit of... Guys, please, first thing is to redraw your free body diagram, right? Redraw the diagram. All right, do we have answers? Okay, can we change that diagram quickly? What would that diagram be like? Quick, let's run. I'm going to have that, right? I'll have this. Is that fine with us? I'll have that. And I'll have this. Quickly, let's work. What is this? FG what? Perpendicular. What is that? FG parallel. What's my formula here? MG sine alpha. What's my formula here? MG cos alpha. What is that? F applied. And that is what? Normal. Since the object is accelerating, which forces are we using? We're using our horizontal what? Forces. That. Do we agree? It's very simple and straightforward. That's what we're using. Lovely. What's our formula? F net equals to MA. But the object is not what? Moving. So what do we have? Okay, so F net would be equal to what? 0. But the object is moving forward. How many force? This one is positive and that one is what? Negative. What's our F net? Force applied plus negative what? FG parallel equals to 0. Do we agree? So what do we have? Force applied equals to what? FG parallel. So our force applied, what's the formula for FG parallel? MG sine alpha. Do we know our force applied? 5,000. We don't know the mass. What is G? 9,8. Sine what? 15. What is the total mass going to be? 1971,28. But this is a total mass. Mass of elephant, therefore, would be what? 1971,28 minus 800. The mass of the crate. What's your answer? 1171,28 kilogram. Guys, is it making sense? Please, I've always said when we get here, our answer lies in your free body what? Diagram. Always. And trust the process. I'm going to run because of time. What's our next question? The crate is now pulled up at, now it is moving at constant acceleration. What does on the first thing on the elephant and increase? Will it decrease or remain the same? It will increase. Because the object will accelerate in the direction of the what? Net force. Now that the object is accelerating, net force will also what? Increase. Guys, we are actually done. Your answer in 2.3.1. Newton's second law. All right. Acceleration is directly proportional to what? Net force. That's what the law says. So A is directly proportional to what? F net. If A increases, net force will also what? Increase. Guys, some good marks there for us. Look at the next one. In another experiment, learners investigate the forces acting on an object at an inclined plane, on an inclined plane. The object has a gravitational force of 98 newtons. The ratio of the normal force to the parallel component was 7:4. This is now maths. Define normal force in words. I'm sure we can go through that quickly. Force exerted by the surface on the object, and it is perpendicular to the surface. Please get those 2 marks. Can I quickly help us with this one? Calculate the angle of what? Inclination of the ramp. Let's go back. Let us investigate the force acting on what? On an object. All right? The object had a gravitational force of 98. Now, they said the ratio of the normal to the what? parallel component. Let's interpret. Okay, what parallel component do we have? If I were to draw this, I would have what? My FG parallel this way, right? Is that fine with us? And they give us the normal force. Okay, here again they are using components, right? Good. What would I have here? FG what? Perpendicular. What is this 98? Are you sure? They said, check this. The object has a gravitational force. This is FG. No. Why are we adding? No. This is FG. Remember what this formula is. This is what? mg cos what? Which is basically what? FG cos alpha. Now we already have our FG, which is what? 98. Now, can we change that into maths? The normal, they said the ratio of the normal to what? Component is equal to what? 7 over 4. What is your normal force? That's my normal force. So what do we have? FG perpendicular over what? FG parallel equals to what? 7 over... Is that making sense to us? Now, what is my FG perpendicular? mg cos alpha over what? mg sine alpha equals to what? We don't even need all of those. What is cos over sine? 1 over 10. To make it easy, we can change it. Sine over cos equals to what? 4 over 7. 10 alpha now is what? 4 over 7. What would that give us? So it's a matter of interpreting now again. So don't add. We just interpret. So the examiner was giving us the weight, which was not necessary though. In fact, I wouldn't have given the weight to make it more complex and look undoable. Because do you notice we didn't use the 98 at all? Now, when they say calculate the angle, they say, but there's no numbers. So again, this goes back to what you do. You need to listen to you. You need to listen to yourself whining. Oh, they give us that. There's no single number, and they want the value. Oh no, these examiners are wicked. How do you bring numbers out of letters? You know. So, guys, again, it's all about interpretation. Are we okay there? All right. Can I link, since we are doing this, can I link this to work energy and power quickly? I remember with SJA learners, I remember we did this question. I just saw this and I remember. All right, let's quickly deal with work energy and power now in the few minutes that we have. Leslie, I don't know those people. All right. Let's make it bigger. Let's quickly run through this. My lights would be off in the next 15 minutes, but let's see what we can answer. Or in the next 10 minutes, I should say. But let's see what we can answer here quickly. All right. Vicky, a 75-kilogram learner, jumps off a bridge. She was supposed to be writing exams. But she's trying to commit suicide. I think she wrote the hotel. This was after the hotel question. Yeah. Okay. Vicky, a 75-kilogram learner, jumps off a bridge 60 meters above the ground. She has a bungee cord tied to her ankles. She falls 25 meters from the bungee cord before the bungee cord begins to stretch. Okay, hold on. I want us to read that and interpret. So she tumbles down in a free fall. Is that okay? The rope was not doing anything there. The rope only began to work when the rope was extended, which is 25 what? 25 meters. No, 25 meters. The rope only extended at 25 because the rope is 25 meters long. She falls 25 before the bungee rope started. So that means all of this from the beginning to this point. Oh no. From the beginning to this point, she's actually in a what? In a free fall. All right. Now, she falls 25 meters, slow it, before the cord begins to stretch, slowing her down. The cord stretches 20 meters before the jumper comes to what? Rest. Ignore air friction. Hence, free fall makes sense. Write down work energy theorem in words, guys. Please, there are things that I'm insisting that those 2 marks are for free. Work energy theorem. Guys, we just changed this into English. That's all. Use the formula and change it into English. Can we change that into English? The net work done on an object. What's the next symbol? It's equal to the what? Change in kinetic what? In its kinetic energy. Oh, they said in words. In kinetic energy. Please, very easy. Number 2, question 2. Use energy principles to calculate what? The kinetic energy of the jumper when she had fallen 25 meters. I told you this, that guys, in these questions, I only use one formula all through. And it makes it, I just use that. So please, let's learn that again. Work done by what? Non-conservative equals to what? Change in EK. Because this is energy principles. We're not using any. When we say energy, what is this? Kinetic energy. What is this? Potential energy. What is this? Work. What is work? Energy. Some people say, but this is not energy principles. I want to know what this is. And it's a free fall, right? And in that free fall, the work done by non-conservative is equal to what? 0. Please, it is the expansion that matters for me here. What is this? Okay, wait. Check what we are looking for. We are looking for what? The kinetic energy of the jumper. So, let's create a diagram. We're looking at this, right? So this is at the top and bottom. Can we call this initial? Oh, I don't want to lose this recording, so I'm just going to stop on this question. And this is called the final. So what are we saying here? EK final minus EK initial plus EP final minus what? EP initial. Please, if you don't read the question, you'll be doing double work. We are looking for the kinetic energy here, EK final. I don't think we should be using half MV. Because you'll get stuck. We don't even know the velocity. So we are looking for what? EKF. What's the initial kinetic energy from rest? Velocity is what? 0. So if my velocity is 0, kinetic energy, do you remember this is a repetition of the multiple choice? So that will be what? 0. Plus, now what is potential energy? mgh final minus 0. No, I think I switched it. It is 0. Yeah, because, we're correct. This is 25 meters, right? So the initial height is 25. The final height is what? 0. Guys, you're not reading the question. Let's read the question. Use energy principles to calculate the kinetic of the jumper when she has fallen 25 meters. So we are working in the frame of 25 meters. This, remember here, it's a free fall. I have already said 0. So I am dealing with just a free fall section. I can't bring in the 20 meters. Because at the 20 meters, it's no longer a free fall. There's an applied force. All right? So final velocity, final height is 0. Initial height is 25. But hold on. mgh final. My final height is what? 0. So it means my potential energy is what? I did that again when we did that multiple choice. That at the bottom, the potential energy is 0. Okay, but what is this one? mg initial height. And this is what? 0. Guys, can we just substitute now? 0 equals to, we are looking for this, right? EKF 000 minus, do we know the mass? 75. She must weigh a lot. What is G? 9,8. Okay, sorry, women. Sorry, ladies. 25. Guys, can you quickly calculate for me? What is the kinetic energy? Final. It's negative here. We bring it here. It becomes 18,375. And what's your unit? Joules. Please, I hope what I've done here makes sense. I'm going to need to shut down now, but I hope it makes sense. That once we have an isolated system, the work done by non-conservative is equal to what? 0. Guys, please, are we okay? What I would do is, I'm going to send this PDF. Please walk through the remaining questions. Okay? And whatever we've done, I did multiple choice to help us deal with all of these questions. Please, let's walk through, okay, before our next session. You have enough days to practice, guys. There's nothing stopping us from working through. Also, the playlist from the previous sessions we have, please go back and walk through some of those concepts. Walk through a concept, check the video, and I'm just going to put everything together in our next lesson. Leslie, you may please send your question on WhatsApp so that I can respond to it accordingly.